Bismillahirrahmanirrahim. In this video, we will discuss about the solution. What is solution? So I can say, and how the solution will be prepared on. So we can say that solution is composed of two components. The first one you can say that is the solute, and the second one is the solvent. So with the combination of solute and solvent, we can get a solution. So the solute, we can say that is that component of the solution which is present in small amount, while the solvent is that component of the solutions which is present in you can say large amount. So the we can say the solute is the substance that is dissolved, and you can say the solute is that component of the solution that is to be dissolved, while the solvent is that component which dissolved the solute. So you can say the solute is dissolved while the solvent dissolves the solute. So you can say that these are the two components of solutions. So by the combination of solute and solvent, we can get a solution. So this one. So you can say, for example, we have you can say a salt. We have a salt in the form of solute, and that is we can say the example of we can take example of sodium chloride. This is a salt which is considered as a solute, and the other one is here is water, which is a solvent. So if we add solute, I can say sodium chloride salt into the water. So the sodium chloride will be dissolved by the water. So the water is a solvent, and the sodium chloride, you can say this is the solute. So by the combination of salt, you can say sodium chloride, and water, we can get a solution. So you can say that solution is composed, as we know, that solute and solvent. So we can say sometimes solutions contain more than one solute which is dissolved in a solvent such as water. So those solutions which contain more solutes, example, if you can say that is a soft drink. So this is the solution which contain more than one solute, and for example, this is a sugar, salts and carbon dioxide which has been dissolved in water. So soft drink is a solution that contain more than one solutes which are dissolved in a solvent like water. So we can say that some solutions contain only one solute, such as sodium chloride dissolved in water, while some solutions contain more than one solutes, such as soft drinks, we can say which contain sugar, salts and carbon dioxide, which are to be dissolved in water. If we take another example of solutions which is air, so we can say that air is also a solution which contains solute and solvent. So in this case we can say that the nitrogen in air is a solvent because it is present in large amount. I can say that the other gases such as oxygen, carbon dioxide and other trace gases are solutes because these are present in small scale. So you can say that these are the solutes which are present in small amount in air. So air is also example of a solution which contain more than one solutes which are dissolved in nitrogen. Now there are three types of solutions. So the first one is a solid solution, the second one is a liquid solution, and the third one is a gaseous solution. So the solid solution is the one which is formed by mixing different metals. So such as we can say. So the solid solutions, we can say this is formed by mixing different metals. Example is you can say this brass, bronze, and steel. So these are solid solutions which are formed by mixing different metals. The other type of solution is we can say this liquid solution. So the second type of solution is liquid solutions, such as carbonated drinks, which are formed by mixing carbon dioxide in water. So in this case, carbon dioxide is a solvent, is a solute, while the water is a solvent. So this is the type of liquid solution. And the third one is we can say this is the gaseous solutions. So gaseous solutions are those which are formed by mixing a solute of the solvent. So the example of the gaseous solution is a smoke, which is a gaseous solution, and this is formed by the combination of carbon particles in a gaseous air. So smoke is an example of gaseous solution because it contains carbon particles which are solutes, and they are mixed in gaseous air, and gaseous air is a solvent. The other examples of solid solutions are, we can say this is this solid solutions. In this case, copper mixed in a gold. An example of is an example of solid solution. So this is a solid solution in which copper is mixed in a gold. So this is a Li. So you can say the second example is mercury mixed with the sodium amalgam. So this is the example of solid solution. So we can say the second one is example of liquid solutions. So such as if you mix ethyl alcohol in a water. So this is the example of liquid solutions, because in this case ethyl alcohol is a liquid and is a solute in the form of solute, while that of water is a solvent, but in the form of but in excess amount. So you can say ethyl alcohol is a small amount which is a solute, and the water is a solvent which is in large amount. So this is the example of liquid solution. And the second you can say the solid and liquid solution. So in this case we can say this is also the liquid solutions, but in this case the liquid is in large amount, such as we can say the water is a solvent is a large amount, while that of the solid in the form of sodium chloride is in small amount. So this is the example of solid liquid solutions, or we can say this is the liquid solution. So the third one is a gaseous solutions. We can say the gaseous solutions are also in the form of liquid gas and gas mixture. So let's take example of this solution. So we can say the gaseous solutions, the example of gaseous solutions are in the form of, we can say liquid solutions, such as water vapors which are mixed in air, or you can say cloud. So the water and the air are both, we can say the air are both in the form of but this air is this is a gas, not in the gas form, but this is a cloud in the form of liquid form. So therefore this is also the liquid. So water vapors is a liquid, and air is also in a liquid in the form of cloud. So the second one is the gas and gas solution. So this is a mixture of helium and oxygen gas. So this is the example of gaseous solutions. Now solutions are also of two types. You can say these are the aqueous solutions, and the second one is the organic solutions. So aqueous solutions are those solutions which are formed by dissolving a substance in water. You can say this one. So in this case, the solvent is a water. The aqueous solutions are water based, and the example of these solutions, you can say this is the salt, such as sodium chloride, which is dissolved in a water. So in this case, we can say as the sodium chloride is dissolved in a water, so on this basis we can say this is the aqueous solutions, because solvent here is water. The on the other hand, we can say these aqueous solutions are polar in nature. So you can say these are common in biological and chemical processes where water is the medium. So in short, we can say that in aqueous solution, water is used as a medium or as a solvent. On the other hand, we can say that organic solutions are formed by dissolving a substance in the organic compound like ethanol, benzene. You can say ethanol, benzene, and ether also. So you can say in this case the solvent is the organic compound such as ethanol, benzene, and ether. So the example of this solution is iodine dissolved in hexane. So you can say in this case the iodine is solute, while that of hexane is a solvent, but hexane is the solvent and is an organic compound. So on this basis we can say that these are organic solutions. So organic solutions are, you can say, these are non-polar. Because here organic solvent is used which are non-polar. So as we have discussed in aqueous solutions that in which water is used, but in organic compounds, as organic solutions, I can say organic compound is used as a solvent. So therefore we can say that solutions are aqueous and organic solutions. So we can say that solutions are also the best of its solubility of dissolving a solute. These are of three types. The first one is the saturated solution, and the second one is unsaturated, and the third one is the supersaturated solutions. So the first one, you can say this is the saturated solution. This is the solutions that contain maximum amount of solute. So you can say at a given temperature. So the saturated solution contain maximum amount of solute at a given temperature, and in this solution the undissolved and dissolved solutes are in equilibrium with each other. So you can say, and the second one is the unsaturated solution. We can say, so we can say the unsaturated solutions contain lesser amount of solute at a given temperature. So we can say that the solutions which contain lesser amount of solute than that which is required to saturation. For saturation, that is, you can say this is the unsaturated solution. Such solutions have the capacity to dissolve more solutes to become saturated solution. So you can say the unsaturated solution are those which is always a capacity to dissolve more solute if we add. So these are neither saturated and nor supersaturated. You can say these are the unsaturated solution. So the supersaturated solution, you can say these are the solutions which are on heating. The saturated solutions have the capacity to dissolve more solute than is required for saturations, which is known as a supersaturated solution. So you can say if we heat the saturated solution, so we have the ability to dissolve more salts because we have heated the saturated solution, And if after heating during heating, you can say that when we dissolve more solutes in the solution become super saturated. So this solution is called super saturated solution. Now here we can see that the unsaturated solution is this one. So you can say that this contain lesser amount of solute as compared to the other two. So this is the saturated solution. So this one you can say, and this contain more solutes, which are these one as compared to unsaturated solution. So you can say the saturated solution contain more solutes as compared to unsaturated solution. Similarly, we have super saturated solution. You can say that on heating we get super saturated solutions which contain more solutes, which is this one, as compared to the unsaturated or saturated solution. So you can say this is the super saturated solution, and this is the example. So you can say, because in this you can say we have in unsaturated solution we have less solute, and we have more solute as compared to the unsaturated, and in supersaturated we have more solute than both the unsaturated and saturated solutions. So also we can say that solutions are also of two types. We can say these are the dilute solutions and the concentrated solutions. So the dilute solutions are those which contain small amount of solute, such as this one. We have a solute of small amount, while on the other hand we have concentrated solution which contain we can say more solute, large amount of solute. So these solutions are called concentrated solution because they contain a large amount of solute, while the dilute solutions contain a small amount of solutes. Now we'll discuss about the concentration units. So you can say that the concentration is the amount of solute in a given amount of solvent or solution. So you can say that basically this is the amount of solute which is to be dissolved in a given amount of solvent. So you can say this is the concentration. For example, we have a solvent, so you can say this is the solute dissolved in this you can say solution. So this is the concentration of the solution. So you can say the concentration is noted by different units. I can say that the first one is the concentration unit is you can say this is molarity, and there are also other units such as normality, formality, molarity. You can say different units. But first we will discuss about the molarity, that we can say what is the molarity of the solution. So you can say that molarity is the number of moles of solute which are dissolved in a liter of solution. So this is called molarity, which is a concentration unit. If you take example of the molarity, we can say we have, for example, we have 0.491 gram of we can say of solute which are dissolved in 400 ml of water, you can say. So of solution, you can say this is a 400 ml of solution. So what will be the molarity of this solution? So now we will determine the molarity of this solution. Now we have, I can say, we have 0.491 gram of solute which are dissolved in 400 ml of water. So now we have to determine its molarity. So we know that molarity is equal to number of moles of solute. So we can say moles of solute per liter of solution. So liter of solution. So now we need here the number of moles of solute and solution in liter. So first we will determine the you can say mole of solute. So you can say, so how we can determine the mole of solute. So you can say that here we have 0.491 the gram of solute. So we can write here that 0.491 gram of solute. So we can say if we have, so here the you can say the solute is you can say solute if we consider that solute is NaOH sodium hydroxide. So it has formula mass of 40 gram per mole. So this is the formula mass of sodium hydroxide, which is a solute in this example. So we have 0.491 gram of sodium hydroxide. So we can say we will now determine the moles for this solute. We will write here say 40 gram of solute or NaOH per mole of you can say. Now in this case gram and gram will be cancelled, and from this we will get we get here the you can say that that will be equal to 0.491 mole divided by 40. So we can say if we divide 0.491 by 40, so we can say that we will get 0.012275 mole of NaOH. So we can say we have determined the mole of NaOH. So now we will determine the molarity. So we can say that molarity is the number of moles per we can say mole per liter. So now we have mole of 0.12275, but we have the volume of 400 ml. So we can say that in order to convert the 400 ml, and that will be equal to, we can say if you divide it by 1000, so we will get 0.4 liter of this solution. So we can say now we can write that number of moles which is number of moles which is equal to 0.12275 moles, and that will be divided by 0.4 liter. So if you divide 0.12275 divided by 0.4 liter, so we will get 0.0306 0.0306 mole per liter. So we can say, or we can write that this will be equal to molarity, and molarity will be 0.0306 mole per liter, or you can say molarity. So you can say in this way we can determine the molarity of a solution, such as we have determined the molarity, which is 0.0306 molar of point. You can say when we dissolve down, we can say that when we dissolve dissolve point 4, we can say that here we have dissolved point 4 0.491 gram of solute, which is NaOH, sodium hydroxide, in 400 ml of water, or you can say 0.4 liter. So from this we have got 0.0306 molar solution of you can say this NaOH. So in this way you can determine the concentration in the form of molarity of sodium hydroxide. Now this is the dilution numerical. So you can say we have a solution of 4.281 molar of volume 10 ml. So if we dilute this solution of 10 ml to 50 ml, so what will be its concentration? So we can say our molarity remains of dilutions. So now we can say that here we have, for example, we can write that we have concentration of A. You can say that this is the initial solution of 4.281 molar, and the volume we can say are we can say this is the volume of A, which is 10 ml. So and you can say we have to, if we dilute it this solution into 50 ml with the volume will be VB, so this is 20 ml. So what will be its concentration CB? So CB is unknown. So now we will put the formula. The formula is we can say that C A we can say VA, and that is equal to CB or VP. So the C, the concentration in solution, V is the volume. So we have CA, we can say this one 4.281, and this is the molarity, so molar, and we have volume VA, which is 10 ml. So we can say that is equal to CB, and CB is you can say unknown, so we write here is the same, and VB will be equal to 50 ml, because this is the volume to which solutions has been diluted. So now we will determine this CB. So we can say that CB, the concentration of dilution will be equal to 4.2 you can say 4.281 m molar into 10 ml, you can say divided by that will be divided by you can say this is divided by 50 ml, so 50 ml. So here you can say that unit ml will be cancelled, and we have only now a unit of m. So you can write that CB will be equal to 4.281 molar into 10 divided by 50. So if we divide and multiply these all, so from this we can get 0.856 we can say molar m. So we can write here that Cb will be equal to 0.856 molar. So this is the final concentration we have obtained, because the initial concentration was this one, 4.28, and we diluted this concentration from 10 to 50 ml. Okay, we have got this concentration, which is 0.856 molar. So from this we have noted that after diluting a solution, its concentration decreases like this one, which is decreased from 4.281 to 0.8056 from after diluting from 10 ml to 50 ml. So in this way you can determine the concentration of a solution after dilution. So this is the example of molarity. Now we will discuss the second concentration unit, which is normality. Previously we have discussed about molarity. So normality is, we can say, the number of equivalents of solute per liter of solution. So in molarity we have discussed that molarity is equal to number of moles per liter of solution, but here in this case we have equivalents instead of mole. So we use equivalents instead of moles, because in molarity we have used you can say moles per liter. So here we will use equivalents per liter. So this is the molarity. So you can say that equivalence depends on the type of reaction. So you can say that in acid base reaction, one equivalent is equal to the amount that donates or accepts 1 mole of hydrogen ion or hydroxyl ion. So you can say that the equivalent depends on the mole of hydrogen ions or hydroxyl ions. So you can say, while on the other hand, so we can say that the equivalent is the formula weight divided by number of hydrogen ions or hydroxyl ions that are donated or accepted. So we can say, if we take example of sulfuric acid, so in case of sulfuric acid, we have two hydrogen atoms here. So we can say that now we can write here that in sulfuric acid it has a formula of 98 you can say gram per mole. So as it can donate two hydrogen you can say ions, so we can say two protons. So we will divide on the formula weight by 2. We can say n is a 2 and this is a formula weight. So this you can say 98 divided by 2, and from that we will get 49. So we can say, we can also write here that this will be equal to 98 we can say gram per mole. This is the formula weight of sulfuric acid. So we can say, when we divide this by 2, so 2 is equal to, that 2 will be equal to equivalent per mole. So you can say, in this case mole and mole will be cancelled, and this you can say, and this 98 will be divided by 2, and when we divide 98 by 2, we will get 49. And now we have a unit of gram and equivalent remaining So you can say that this will be equal to 49 gram per equivalent. So we have the equivalent weight of sulfuric acid, which is 49 gram per equivalent of H2SO4. So in this way you can determine the equivalent weight of sulfuric acid in case of acid-base titration. So we can say that the other one is redox reaction. So in redox reaction, we can say in case of normality, we will determine the equivalence of redox reactions. So in order to determine the equivalent in redox reaction, we can say in this case the equivalent will be equal to the amount that donates or accepts 1 mole of electrons. So here in redox reaction, the number of electrons are concerned instead of hydrogen ions or hydroxyl ions. So we can say that the equivalent is the amount that donates or accepts 1 mole of electrons. So in redox reaction, you can determine the equivalence of you can say compound, keeping in view the number of electrons which are donated or accepted. For example, we have potassium permanganate. So you can say this potassium permanganate, you can say that in specific conditions in the presence of acidic media, so we can say that it is converted into Mn plus 2, manganese plus 2. So you can say in this case the manganese is in plus 7 oxidation state, and it will be converted into plus 2 oxidation state by you can say by gaining 5 electrons. So as we have previously discussed that here is the amount that donates or accepts mole of electrons, 1 mole of electrons. So you can say that in case of potassium permanganate, it can accept 5 electrons, and by accepting 5 electrons, you can say the same is converted, the manganese is converted from plus 7 into plus 2 oxidation states. So you can say here the redox reaction occur. So because the valency is reduced from plus 7 into plus 2 oxidation state by gaining 5 electrons. So you can say this is the redox reaction, and here the number of electrons is concerned. So now we will determine the formula weight, equivalent weight of potassium permanganate. So we know that the formula weight of potassium permanganate will be equal to we can say, so the formula weight of KMnO4 is you can say 158 gram per mole. So if we want to convert it into equivalent weight, so we can say that the equivalent weight of potassium permanganate will be equal to 158 you can say gram per mole divided by, as we have discussed that it can gain 5 electrons. So in this case the formula weight of potassium permanganate will be divided by the 5 electrons, or you can say 5 equivalents, equivalent per mole. This will be the, you can say, the equivalent per mole. So 5 equivalent per mole. Now in this case you can say the mole will be cancelled, and if we divide the 158 by 5, you can say we can get the value of, so we will get 31.6 I can say gram per equivalent. So now we can write here that equivalent weight of can say the K-4 will be equal to this one 31.6 gram per equivalent. So this is the equivalent weight of potassium permanganate. So because here a number of electrons are involved, so we have divided the formula weight by the number of electrons gained by the manganese. We can say these are 5, so we have divided 158 by 5, and from this we have got 31.6 which is the equivalent weight of potassium permanganate. So another one is the precipitation reactions, which is we can say. Then in precipitation reactions, we will determine the equivalent weight for the determination of normality. We can say that in precipitation reaction, the equivalent will be equal to the amount that reacts with 1 mole of charge. I can say, so in case of normality, you can determine the equivalent weight by dividing the formula weight with that of the mole of charge. So this is the precipitation reaction. So you can take the example of determination of normality in case of sulfuric acid. So if we have 0.248 mole of sulfuric acid which is dissolved in 250 ml of solutions, so you can say what will be the normality of this solution. So here we have a reaction of sodium hydroxide with that of sulfuric acid, and it will give this product sodium sulfate in water. So you can say that we have here 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So we can say that as this is the acid base reaction, because the sodium hydroxide is a base and sulfuric acid is we can say the acid. So in case of acid base reaction, sulfuric acid will we can say gives 2 H plus ions. So we can say, so in this case we have 0.248 mole, 0.248 mole of we can say sulfuric acid. So now we know that this is the, you can say, the sulfuric acid mole. So we know that 1 mole of sulfuric acid reacts with 2 mole of sodium hydroxide. So we can write here that 1 mole of H2SO4, and that is equal to, that will be equal to 2 mole of, that will react with 2 mole of you can say NaOH. So you can say that here mole of sulfuric acid, you can say that will be cancelled. So mole of sulfuric acid has been cancelled, and we can get 0.248 into 2 mole of NaOH. So if we multiply, we can say, if we multiply the 0.248 with 2, so from this we can get the point, we can say from this we will get the mole of sodium hydroxide. So if we multiply the 0.248 mole with the 2, so from this we will get the value. So we can get 0.496 mole of sodium hydroxide. So here we have 250 ml. Now we can say that 250 ml this is equal to 0.250 liter. So we will divide 0.496 divided by 0.250 liter. So we can say that if you divide 0.496 by 0.25, and that will be equal to 1.98. So here we can write that will be equal to 1.98 mole per liter. So you can say that will be equal to 1.98 molar. So this is the 1.98 molar of you can say sodium hydroxide will get by reacting the sulfuric acid with the sodium hydroxide. Now if you want to calculate the normality, you can say here we have given a 0.248 mole of sulfuric acid. If you want the normality of sulfuric acid only, so you can say that what will be the normality of 0.248 mole of sulfuric acid. So we know that it contains 2 hydrogen ions. So here you can say that that will be you can say the 2 hydrogen, or we can write here that sulfuric acid contains 2 equivalents per mole, 2 equivalent per mole. You can write here that 0.248 this is the mole of sulfuric acid. So we can say multiplied by 2 equivalent per mole. So mole and mole will be cancelled here, and if we multiply the 0.248 with the 2 from this, we will get 0.248 into 2, and that will get 0.496. 0.496 I can say normal of sulfuric acid. So you can say because this is a mole of here you can say that that will be the 0.496 equivalent of sulfuric acid. Now here we have 250 ml of you can say solution, so which is equal to 0.250 liter. So if you divide this 0.496 by 0.250 liter, so we can say that that will be equal to 0.250 that will be also equal to, so you can say 1.2 the same case, so as we previously done, 1.98 I can say equivalent per liter. So equivalent per liter, this is also equal to normal. So this is the 1.98 equivalent per liter or normal of sulfuric acid. So in this way you can determine the concentration of caustic soda, this one, as well as the normality of sulfuric acid by this reaction. So now we will discuss about the third concentration unit, which is molarity. Molarity, not molarity. Previously we have discussed about the molarity, which was the number of moles of solute per liter of solution. In this case we can say that molarity is equal to number of moles of solute per kilogram of solvent. So this is the number of moles of solute per kilogram of solvent. So this is called molarity. But this is the kilogram of solvent, not kilogram of solution. So in molarity we have discussed that this is the molarity is the number of moles of solute per you can say kilogram of solution, but molarity is equal to number of moles of solute per kilogram of solvent. So we can say in molarity we use solvent, where in molarity we use a solution. So this is the main difference between molarity and molarity. So molarity is equal to number of moles of solute per kilogram of solvent. So you can say, so if we dissolve we can say 1 kg of urea in 1 kg of water, so you can say water is solvent, in this case water is solvent. So we will get 1 molar, you can say that here is 1 mole of urea, this is you can say this is 1 mole of urea in a 1 kg of water. So we will get 1 molar solution. So by dissolving of 1 mole of urea in 1 kg of solvent, I can say water, we will get 1 molar solution. So you can say this is called molarity, molar solution. Molarity is independent of temperature. So this is a molarity, and you can say this is independent of temperature. So if we increase or decrease the temperature, it has no effect on the concentration of molarity. So as we have known that molarity is dependent on temperature. So by increasing the temperature, the volume of solution, you can say, increases. But in case of molarity, is it is the number of moles dissolved in kilogram of solvent. So by increasing or decreasing the temperature, it has no effect on the molarity of a solution. So suppose we have prepared a solution at we can say 20 degree Celsius. Now the amount of solute remains constant, we can say, but the solution volume increases slightly by about 0.1%. So you can say here we have first the volume up to this level, then when we heated this solution from 20 to 25 degrees Celsius, so we have noted that this volume increases from this to this. So you can say this is the increase in volume by about we can say 0.1% increase in volume. So you can say here volume is increases. So by increasing the temperature from 20 to 25 degrees Celsius, we have noted that the volume of the solution we can say increases slightly by about 0.1%. So the number of solute per liter, you can say the molarity decreases slightly by 0.1%. In this case, we have noted that molarity, you can say it decreases, you can say decreases slightly by about 0.1%, because the molarity depends upon the volume, the volume of temperature, volume of temperature, you can say. So by increasing the temperature, the molarity of the solution increases by 0.1%, while the molarity is independent of temperature. If you increase volume from 20 to 25 degree, it is no effect on the concentration of solution. So we can say that molarity is you can say temperature dependent, while that of molarity is temperature independent. Now another one is we can say weight percent solution. So weight percent solution is the solution in which gram of solute, I can say, is dissolved per 100 gram of solution. So you can say percent weight by weight will be equal to, you can say that this is the mass of solute divided by mass of solute divided by mass of you can say solution multiplied by 100. So from this we will get a percent of weight by weight of solution. For example, if we have 5% weight by weight solution of sodium chloride, it means that we have 5 gram of sodium chloride which has been dissolved in. From this we can get 5% solution of sodium chloride. It means that 5% weight by weight of sodium chloride solution contains 95 gram of water, in which 5 gram of sodium chloride has been dissolved. So you can say that this will be the 5% of weight by weight solution of sodium chloride. For example, if we have a flask, and this flask we can say if we put on we can say 95 gram of water into this flask here. So we can say and again if we add 5 gram of sodium chloride into this flask. So if we put it this sodium chloride also, so the flask will contain 95 gram of you can say water and 5 gram of sodium chloride, and this flask will contain 5% of sodium you can say chloride solution, 5% of weight by weight of sodium chloride solution. So we can say, so these are called the percent of weight by weight solution. Now we can say that the next one is volume percent of solution. So we can say that volume by volume percent solution means that volume of solute dissolved in you can say in volume of solution into 100%. So this is the percentage of volume by volume percent of solution. So for example, if we have 10% volume by volume solution of ethanol, it means that we have taken 10 ml of ethanol, and the same has been dissolved in 100 ml of solution you can say, and which has been multiplied by 100. So it actually means that we have taken 10 ml of ethanol, and the same has been dissolved in 90% of 90 ml of water. So the total become 100 ml. The total volume become 100 ml. So therefore we can say that is the solution, 100 ml solution. So here is also the volume of solution, which is 100 ml. So from this we can get volume by 10% volume by volume solution of ethanol. So this is the volume by volume percent, because we have divided the you can say the volume of solute by you can say volume of solution. So from this we can get a volume by volume percent of solution. So the next one is you can say this is a weight by volume percent, you can say W by V percent of solution. So what is this? So you can say, so the weight by volume percent you can say this is the mass of solute in gram divided by volume of solution in ml multiplied by 100%. So from this we can get percent weight by volume solution. So for example, we have 0.9% weight by volume solution, saline solution. So it means that we have 0.9 gram of sodium chloride that has been dissolved in enough water to produce total volume of 100 ml, and we can say this will be the 0.9% weight by volume saline solution, because this solution contains 0.9 gram of which is expressed in a weight, because it is 0.9 gram. So this is you can say this is W weight 0.9 gram, and it has been dissolved in 100 up to 100 ml. So you can say this is the volume. So therefore that is called weight by volume solution of saline, which is 0.9 gram. So this is called weight by volume percent of solution. The other concentration unit is a mole fraction. So what is mole fraction? So you can say the mole fraction is the ratio of the moles of solute to the total moles of solution. So here you can say that X is a mole fraction. So this is the mole fraction, and that is equal to so you can say this the moles of solute divided by moles of solute plus moles of solvent. So this is called a mole fraction. So you can say, so if we have a solution, so you can say that solution contain 1 mole of sodium chloride and 9 moles of water. So the mole fraction of this solution will be, we can say, as we know that mole fraction is equal to moles of solute. So moles of solute, you can say that is a 1 mole, that will be 1, because 1 mole of solute is this one, divided by moles of solute plus moles of solvent. So moles of solute is a 1, you can say a mole of solvent, so this one 9 mole of water, and this one. So you can say from this we can get the mole fraction of 0.1. So you can say that this solution has mole fraction is equal to 0.1. So in this way you can determine the mole fraction of a solution. So now we will discuss about the that how to prepare molar solutions. So we can say that here I will tell you an easy way to prepare the molar solution. So for example, we want to prepare the molar solution of concentration 0.1 molar and volume 500 ml. So how this solution can be prepared, or we can say how many grams should be needed to prepare this solution. So you can say that we have to determine the gram which is needed to prepare this solution, and that will be the solution of sodium hydroxide, of you can say caustic soda, and the caustic soda has a formula weight of so you can say that is a 40 gram per mole. So now in order to prepare to determine the gram required to prepare this solution, so you can say we have to carry out the stoichiometric analysis for determination of grams. So you can say that we have to prepare first 0.1 molar, and 0.1 molar is equal to 0.1 mole per liter, or you can write here in the same way that 0.1 millimole per ml. So you can write in this way also. Now the volume required is we can say this is 500 ml. If we convert the 500 into liter, so we know that 1 liter is equal to 1000 ml, will be equal to 1 liter. So ml and ml will be cancelled, and from this we can get 0.5 liter. So 500 ml will be equal to 0.5 liter. Now in order to determine the gram required for these solutions, so we can write here that so you can say that 1 millimole per ml. So this is the concentrations we required for determination of we can say this is the concentration of the sodium hydroxide solution we have to prepare. So multiplied by the volume, we can say this is the 500 ml. So 500 ml is equal to, we can say that is 500 ml. Now here we need ml because here is also an ml. If in the denominator here is liter, so we should write here also a liter. So you can say that now ml and ml will be cancelled. So we can say that we have in this regard ml will be cancelled, and from this we will get 0.1 into 500 millimole. So 0.1 into 500, and you can say this will be equal to 50 millimole. So this is equal to 50 millimole. So we can say that we have obtained 50 millimole. Now we should multiply the 50 millimole, you can say, with the formula weight of the sodium hydroxides. So we can say that it is 40 milligram per millimole. So 50 milligram per millimole. So millimole will be cancelled, and you can say if we multiply the 40 with the 50, so we can get 2000 milligram. So now we have obtained 2000 milligram. In order to convert this milligram into gram, so we know that 2000 you can write here 2000 milligram is will be multiplied by, you can say, we know that 1000 milligram is equal to 1 gram. So milligram will be cancelled with this one. So if we divide 2000 by 1000, so we will get 2 gram. So you can say that here we have the only gram of unit remaining, so this will become 2 gram. So because this zeros, 3 zeros will be cancelled, so we have remaining digit is 2 and the unit is gram. So we have obtained 2 gram, we can say. Now 2 gram of NaOH will be taken. But if we can say in this case the solution, the sodium hydroxide we want to take if its concentration is its percentage purity is, for example, 98%, so then what will be done in this case? So we can say that we will simply multiply the 2 gram required, 2 gram of NaOH required with we can say 100 divided by 98. So if you multiply the 2 gram with 100 divided by 98, so from this you can get 2.04 gram of NaOH. So we can say that now we can write here that 2 gram of NaOH will be taken. I can say 2.04 gram for this innovation will be taken, and dissolved, and the same dissolved up to 50, you can say up to 500 ml, 500 ml in a flask. So in this way we can prepare the we can say the 0.1 molar solution of we can say caustic soda. So this is innovation. So and the same we will take it in flask. For example, we have here a flask. So first we have to take 2.04 gram of NaOH of percentage 98%, and this will be added in this flask. After addition of this NaOH into the flask, then we will add DMW into the flask and make the volume of to we can say this 500 ml. So this is a flask of 500 ml. So as you can say that will be filled up with the DMW, you can say after this mark of 500. So now in this way you can prepare the molar solution of caustic soda and other you can say salts, acids and bases. Now we will discuss that how to prepare ppm solutions. So for example, so in order to prepare the ppm solution, so we can say, for example, we have to prepare 50 ppm solution of concentration 250 ml. So of nickel chloride hexahydrate, which is formula weight 237.71 gram per mole. So how many grams should be needed to prepare this solution, we can say. So now we know that so here we know that the ppm is equal to milligram per liter. So we can write here that milligram will be equal to ppm multiplied by liter. You can say from this formula you can write that milligram is equal to ppm into liter. Now in order to prepare the ppm solution of salt, we can say that we will multiply the ppm by liter with the gravimetric factor. So we can say that we have a salt of nickel chloride. So we have to prepare the standard solution, you can say, of nickel from the salt of nickel chloride. So we have to prepare standard solution of nickel. So now we will first make the gravimetric factor. Now in order to prepare the gravimetric factor, we should know the formula weight, which is of nickel chloride, which is 237.71 gram per mole, while that of the formula atomic weight of you can say nickel is equal to 58.71 gram per mole. So gravimetric factor will be equal to in this case we can say that gravimetric factor will be equal to gravimetric factor will be equal to, we can write in such a way that this milligram will be equal to ppm, and we have to prepare I can say 50 ppm solution. So we can write here the 50 ppm 50 you can say 50 ppm, and of volume in liter. Here we have 250 ml, so it will be equal to 0.250 liter. So we can write here that that is equal to 0.250 liter into a gravimetric factor. So gravimetric factor is equal to formula weight to the salt ton. You have to use for you can say making ppm solution, and divided by the element of which ppm solution is to be prepared. So here we have a salt of nickel chloride, and we have to prepare the nickel solution. So we can say that here we can write that gravimetric factor will be equal to we can say we have a formula weight of 237.71 or we can say divided by the atomic weight of nickel is 58.71. So now we can write that milligram will be equal to we can say that if you multiply this one like this, so 50 500 we can say this is a 50 ppm. We can have written 500, so here is a mistake for this one. So you can say we have 50 ppm, not 500. So 50 ppm is equal to milligram per liter. So you can say that this is a 0.250 liter, and you can say here that liter and liter will be cancelled. So we have a unit of milligram, and gravimetric factor 237.71 divided by 58.71. So you can say that if we multiply this one, we have 50 into 0.250 into 237.71 divided by 58.71, that is equal to 4.048. So this is the gravimetric factor. So you can say, and this is also gravimetric factor we have written here. So from this we can say the unit will be remains will be milligram. So if multiply, so all these we can get 50 .60 I can say 61 milligram. So if we convert the milligram into gram, so we can say we will know that 1000 milligram is equal to 1 gram. So here milligram and milligram will be cancelled, and if we divide the 50 by we can say by 1000, we can get 0.0506 gram of you can say nickel chloride hexahydrate. So you can say that this weight 0.0506 gram of nickel chloride will be taken, and the same will be dissolved up to we can say in a DMW up to volume of we have here 250 ml. So 250 ml. So we can say that we have to take in a flask the same. For example, we have here a flask. So in this flask we have to take a point 0, so you can say 0.0506 gram of nickel chloride and hexahydrate, and this will be taken and add into this flask. After that DMW will be added to the same flask and make the volume up to 250 ml. So in this way you can say we will get 50 we can say we will get 50 ppm nickel solution, standard solution. So in this way you can prepare the ppm solution of elements, you can say of different elements. So this is another way to prepare these solutions. So now we will discuss about how to prepare 2 normal sulfuric acid solution of volume, we can say 1 liter. So we have we can say a stock solution of sulfuric acid which is equal to 18 molar, or you can say 36 normal. So now we want to prepare 2 normal solution, so you can say of sulfuric acid of concentration you can say 1000 ml. So now use the dilution formula. We have C1 V1 is equal to C2 V2. So you can say that we have C1 36 you can say normal into V1 is equal to concentration C2, that is we have to prepare this, it is 2 normal, and volume we can say the volume is I can say 1000 ml. So now the V1 volume required for preparation of 2 normal solution will be equal to 2 normal multiplied by 1000 ml divided by 36. So you can say, so that will be equal to 55.55 ml. So we should take out 55.5 ml of you can say concentrated 36 normal solution, and we will put into the water and make the volume to a final volume up to you can say 1 liter. 1 liter. So here we can say that we have a flask, and in this flask we will first add DMW first, and this and second we will add on the H2SO4 you can say 36 normal of you can say 55.55 ml. So we should add into the flask then again and make the volume up to you can say 1 liter. So I can say 1000 ml. So in this way you can prepare the 2 normal solution of sulfuric acid from stock solutions.